Hi everyone, welcome back to Learning with Haneen. In today's video, we're going to continue going over the June 2024 Algebra 2 Regents, and I deeply apologize for the delay in uploading parts 2, 3, and 4 of the Algebra 2 Regents exam. So with that being said, make sure to like, share, and subscribe. Comment down below any topics that you are still having trouble with so I can make sure that I can post some videos prior to the test, which is on Monday, August 19th. If you have any questions, please let me know. Make sure to share it with all your friends if they are taking the Algebra 2 Regents again on August, or if they're going to take it as a class next year. And also tell me down in the comments which classes you guys are going to be taking next year so I can start uploading and making videos that are going to align with the math classes that you guys are going to be taking next year. So without further ado, let's get started. So we're going to start with part 2. And part 2 contains 8 questions, and we know that each correct answer will receive 2 credits. You are to use pen for this part. Only thing that should be done in pencil is graphs and drawing. So, question 25 says, given x is a real number, write the expression in simplest a plus bi form. So, prior to doing this, because I know we have I, I'm going to just show you the rules for I. So, the rules for I, we have I to the 0 or to the 4th power is just 1. I to the 1st power is I squared is -1, and I cubed is -I. So it's really important for you guys to remember these when doing these types of questions. So first things first is I'm going to take this part. So I have x plus 2I times 3 minus 2xi. So first things first, x times 3 is 3x. And then x times -2xi, I'm going to get -2x squared I, because x times x squared, we just bring the I down and it's 2. And then I'm going to do here, so 2I times 3 is going to be 6I. And then right here, 2I times -2xi, I'm going to get 4xi squared. And then I'm going to bring it down this part, so plus 2x squared I. So when I'm going to combine like terms, I'm going to combine the -2x squared I and the positive 2x squared I, and because they're the same, they're one's negative and one's positive, they're going to cancel out. And then we look here, we have to simplify our I. So we know that I squared is going to be -1. So when I rewrite this, I have 3x plus 6I minus 4x, so I squared is going to be -1. So when I rewrite this, I have 3x plus 6I plus 4x. Then I'm going to combine like terms again with my 3x and my 4x. It's going to be 7x plus 6I, and that is going to be my final answer in A plus bi form. So I just combined, I FOILed the first part, this part right here, and then I added this part, and because these two cancel out, because one's positive, one negative, they cancel out. What I'm left with is 3x plus 6i minus 4xi squared, because I squared is -1, so I have -4x times 1 is going to be positive 4x, and then 3x plus 4x is 7x, and I just bring down my 6i. And so my final answer is 7x plus 6i. Question 26. Solve 3.8e 1 to the 1.5t equals 16 algebraically for the nearest hundredth, to the nearest hundredth. So this, we have e, and we want to reverse it, we have to use ln. So we're going to do 3.8e to the 1.5t equals 16. First things first, I'm going to divide by 3.8 on both sides. So e to the 1.5t equals 16 divided by 3.8. And then when I simplify that, I'm going to get e 1.5t equals 4.2105 and you just do this in your calculator. Again, to get rid of e, we have to ln both sides. So that cancels out. And ln on this side. And so now I have 1.5t equals ln 4.210526316, and then divide by 1.5 on both sides. And then I get t equals 0.95839177704. Because they're asking to the nearest hundredth, I'm going to put my final answer, t equals 0.96. And so again, you just use your calculator. So we know that when we have E, the inverse is ln, okay? So when we do that, we're going to first divide by the 3.8, and then we get 16 divided by 3.8. You can keep it like this and then just apply the ln, or you can simplify this part and then, it's best to always keep this as a fraction until the end, just because when you simplify it midway, it gets a little confusing and some numbers are not shown, but it's always up to you, but you will end up getting the same answer as 0.96. Sometimes just simplifying it makes it easier to put it into your calculator. But also, I want to remind you, like when I did it, I didn't simplify this answer. What I got on my calculator is what I put back into my calculator, because you don't want to get that mixed up. Question 27. In an attempt to get the student body's opinion of a new dress code, members of the statistics class surveyed the students of the first period computer science class. Explain a statistical bias in the method of data collection. So, what are we trying to do? We're trying to conduct a survey to get the student's body's opinion of a new dress code, and the statistics class decides that they're going to survey the first period computer science class. So let me ask you a question. Are a majority of the students are good population of the students in the computer science class? No. So a statistical bias in this method of collection is that, so a statistical bias in the method of data collection is that the sample of the first period computer science class isn't representative of the entire student body. We can add that the opinion of the students in the computer science class may not be reflective of the opinion of all the students. So whenever you're given a question where it's telling you that they're trying to get data on the student body, the entire school, whatever, you can't take a sample just from one class. Because if you were in school and they wanted to survey students on the new lunch menu, and say they only asked students in fourth period lunch, that's not representative of the population, because say you have 1,000 kids in the school and only 40 kids have lunch fourth period, it's not representative of the entire class. Same thing, if you're doing the same thing but you're going to ask students in first period English, not all the students have first period English. First period English might just be freshmen, might just be sophomores, might just be freshmen and sophomores who may have different opinions from the seniors and the juniors. So you always want to make sure that your sample is representative and reflective of the entire population. Question 28 says, sketch a graph of polynomial px given the criteria below. P of x has zeros only at -5, 1, and 4. As x approaches infinity, p of x approaches negative infinity. And third criteria, as x approaches negative infinity, p of x also approaches negative infinity. So, first things first, I'm going to plot my zeros. So I'm going to do 1, 2, 3, 4, 5, 6, 7. Get the same on both sides. There we go. So we have 1, 0, and -5. So we have a 0 and -5. We have 1 at 1 and 1 at 4. And then we said our condition says that as x approaches negative infinity, p of x approaches negative infinity. So that means that right here, because this is my positive infinity for x, my y is going to go down here. And then on the other side, it says that x approaches negative infinity, p of x approaches negative infinity. So here is my negative infinity for x. Here is my negative infinity for y. Now I have to connect it because it's a polynomial. So what you want to make sure you do is that because we only are given 3 distinct zeros, we don't want to add more zeros. So we're going to very carefully match it so that this is what our graph is going to look like roughly. And so this would be the graph of your polynomial px. It has zeros at -5, 1, and 4. It has as x approaches positive, p of x approaches negative infinity, and as x approaches negative infinity, p of x approaches negative infinity. Question 29 says, the height above ground of a Ferris wheel car can be modeled by the function ht equals -103.5 cosine times 2 pi t over 5 plus 108.5, where h is measured in feet and t is measured in minutes. State the period of the function and describe what the period represents in the context. So when we have this kind of equation, our period is going to be right in the parentheses. And remember, the period is equal to 2 pi over b. So this would represent our, So in here, we're given 2 pi over 5. So we know that our period matches up, and this is going to be 5. So our period equals 5. And what does that mean? It means that it takes the Ferris wheel car 5 minutes to complete one full rotation or one full cycle. Because we know that the period is the time that it completes one rotation in one cycle. Because our period is 5, and we know that t is measured in minutes, we know that it takes the Ferris wheel 5 minutes to complete one full rotation, one full circle rotation. Now for question 30. Solve algebraically for all values of x. So when we're given this type of question, we're going to multiply by our denominators. So we know that our denominators are x plus 5 and x. So we multiply everything, x plus 5 times x. This is multiplied by x plus 5 times x. And this is multiplied by x plus 5 times x. So we know that here, x plus 5 and x plus 5 are going to cancel out. So we have 8 times x minus, here, the x and the x are going to cancel out. So we have minus 3 times x plus 5 equals to 5 times x plus 5 times x. So when we simplify everything, we get 8x minus 3x minus 15, equals, and then we have, this is 5 times x squared plus 5x, and then when we distribute again, we get 5x minus 15 equals 5x squared plus 25x. Then I'm just going to move everything to one side, so I'm going to add 15 on both sides, and then I'm going to subtract 5x on both sides, and then I'm going to get 0 equals 5x squared plus 20x plus 15. And then I want to factor it. And I could see that I have a GCF greater than 1, so I'm going to divide the entire thing by 5, and I'm going to get 0 equals x squared plus 4x plus 3. And so then I need to find two numbers that multiply to get 3, not to get 4, and that would be 1 and 3. So I have x plus 3 and x plus 3 plus 1 set equal to 0, and so x plus 3 equals 0, subtract 3 on both sides, x equals negative 3, x plus 1 equals 0, subtract 1 on both sides, x equals negative 1. And so the common mistake is that once anybody finishes this question, they are so prone to just writing, oh, those are my two answers. But it's very important for you to check, because at sometimes they may not both work. And so I'm going to write here on the side my check. So I'm going to first check for x equals negative 3. So I'm going to put in 8 divided by negative 3 plus 5 minus 3 divided by negative 3 equals 5. So I'm going to get 8 divided by 2, plus 1 equals 5, so that's 4 plus 1 equals 5, 5 equals 5, that is correct. So x equals negative 3 works. Now for x equals negative 1, so 8 divided by negative 1 plus 5 minus 3 divided by negative 1, question mark equals to 5, so 8 divided by negative 1 plus 5, that is 8 divided by 4, plus 3 equal question mark to 5, that would be 2 plus 3 equals 5, 5 equals 5, and that in fact works. So my two solutions are x equals negative 3 and x equals negative 1. Those are my two answers. Although I found out that both answers are solutions, it is very important to check because sometimes they would not be the same answer. So next to question 31 says, the transportation methods used by the upperclassmen at Calhoun High School are summarized in the table below. Are the events being a junior and driving to school independent? Use statistical evidence and justify your using statistical evidence justify your answer. So when they're asking if two events are independent, there's two things that we can use. We can use either their intersection, which is basically saying that the probability of A and B happening equals the probability of A times the probability of B, or we can use the conditional probability and see whether or not the probability of A happening given B equals the probability of event A. So in this case, for me personally, I would do the intersection, but I'm going to show you how to do both ways. So I'm trying to know if probability of being a junior and driving is equal to the probability of being a junior times the probability of driving. So I know that the probability of being a junior and driving is 58 out of, so I'm going to do my totals really quick. So this is going to be 145, 132, 139, 114, 24, and I'm going to get 277. And so I'm going to get 58 over 277, question mark, if it's equal to probability of being a junior, we know is going to be 145 out of 277 times the probability of driving, which is 139 over 277. When I put that in my calculator, I'm going to get 58 over 277, question mark, equals 0.2628, and then I simplify this into fraction and I get 0.20939. Does that equal to 0.268? And it does not. So are they independent? No. the events of being a junior and driving to school are not independent because the probability of being a junior and driving to school is 0.20939, whereas the probability of being a junior times the probability of driving equals 0.26268. So we said that no, the events of being a junior and driving to school are not independent because the probability of being a junior and driving to school is 0.20939, whereas the probability of being a junior times the probability of driving equals 0.26268. And there we have a completed answer. If you were going to do this with a conditional probability, it would just take just a little bit longer. It's just saying that probability of being a junior, given that you drive to school, does that equal the probability of being a junior? So the probability of being a junior, given that you drive to school, so you drive and be a junior, it would be 58 or 139. And the probability of being a junior is 145 over 277. And if we simplify those both, for this we're going to get 0.417. And here we're going to get 0.523. And so we can see that they're not equal. So again, they are not independent because the conditional probability of being a junior, given that you drive to school, is not equal to the probability of being a junior. So there's two ways to solve this question. Just make sure that you show your work and then you give your justification. Question 32 says, can f of x equals x cubed plus 7 be classified as an odd function? So there's rules that you want to remember. For something to be an odd function, f of negative x is supposed to be equal to negative f of x. So what that means is if my f of x is x cubed plus 7, f of negative x would mean that it's going to be negative x cubed plus 7. Negative f of x means that I'm doing negative x cubed plus 7. So I'm going to distribute that. I'm going to get negative f of x equals negative x cubed minus 7. Okay? And we know that for something to be an odd function, f of negative x has to be equal to negative f of x. So because they are both not equal, it is not an odd function. So we can say that no, f of x equals x cubed plus 7 cannot be classified as an odd function because f of negative x of negative x cubed plus 7 is not equal to negative f of x of negative x cubed minus 7. We showed our work and we gave our justification. We said that it can be classified, it cannot be classified as an odd function because f of negative x cubed plus 7 is not equal to negative f of x, which is negative x cubed minus 7.